Hello everyone, this is the part 2 in the video series of clustering and its techniques, and today we'll be focusing on what is hierarchical clustering and what are the types of hierarchical clustering, what is a dendrogram, and what are the different linkages or ways to find a similarity between clusters, and we'll see an example. Now, first let's see what is a hierarchical clustering, but before that let's discuss what are the types of hierarchical clustering. So the types of hierarchical clustering are, first one is agglomerative clustering, agglomerative clustering, and next one is d- divisive, divisive clustering. Now, what is agglomerative clustering? So imagine we have a set of data points like let this be feature 1 and this be feature 2. Imagine we have a set of data points distributed like this. Sorry. So what agglomerative clustering says is initially each and every data point is considered as an individual cluster. Okay. And after that, it tries to merges the clusters which are close to each other. So let's say these two clusters are close to each other, so it merges them. Similarly, if these two clusters are close to each other, it will merges these two. It like this. So initially we started with say 2, 4, 5, 7, 9, 10, 11, 12, 13, 14. Initially we had 16 data points, that is 16 clusters in the first iteration, because each data point is considered as one cluster. So in the second iteration, we merge the clusters which are close to each other. So in the second iteration, we ended up with 1, 2, 3, 4, 5, 6, 7. Second iteration, we had 9 clusters. In the third iteration, we will again merge the clusters which are close to each other. As you can see, this cluster and this cluster is close to each other, so this will become one cluster, and similarly this whole thing will become another cluster. So probably this might end up with 4 clusters, and so on till one big cluster is formed. We'll end up with one cluster which has all the data points. So this is agglomerative clustering. Now what divisive clustering says is uh, say similarly to agglomerative clustering, let's see if the data points are distributed like this. What divisive clustering says is in the first iteration, all the data points are present in one big cluster. In the second iteration, it divides this into two clusters. So this is cluster 1 and this is cluster 2. This is in the second iteration. In the third iteration, sorry, these two clusters are again subdivided into another two clusters. Maybe this cluster is divided like this, and this cluster might be divided like this. So at the end of all the iterations, it will divide till each data points becomes its own cluster. So this is divisive clustering. Sorry. divisive, hierarchical, clustering. Now, when we compare divisive and hierarchical clustering, the most easiest of these two is divisive. Sorry, most easiest of these is agglomerative clustering because it's easy to combine than to divide. We never know like how the cluster should be divided, but computing the proximity between the clusters, we can merge them. So it's easy to combine rather than divide. 1 second. As you can see here, initially we have 6 data points, and the point 1 and 3, they're close to each other, so it formed cluster number 1, and the points 2 and 5 are close to each other, so it formed cluster number 2. And this this is represented in a tree-like structure. As you can see, the 1 and 3 are close to each other, so it formed one cluster C1, and next 2 and 5 are close to each other, so it formed cluster C2, and rest of the points are individual clusters. So this is first iteration. In the second iteration, it says the cluster 1, that is the points 1 and 3, are close to the cluster 2, 2, 5, or it is close to the point 4. This point 4 is closer to which of these clusters? After finding the distance, it's observed that the point 4 is closer to the cluster 2 rather than cluster 1. So it forms another tree-like structure. Basically, it merges, 4 gets merged with 2 and 5 cluster. So this becomes cluster 3. Next, in the third iteration, and this is second iteration, in the third iteration, it says we have cluster C1 and C3, and next it says whether these two clusters are close to each other or it is close to the point 6. And it's observed that cluster 1 is close to the cluster 3, so it forms a tree-like structure, it connects them. So this becomes your cluster 4. And after all the iterations, all the clusters are merged and it becomes a big cluster 5. Now, what is this tree-like structure? This is called as a dendrogram. Dendrogram. Basically, it shows the how the clusters are merged or split. So as we have only less number of data points over 6, that it's represented in a tree-like structure. And what are these lines here? So and how do you identify how many clusters are good for data which is distributed like this? It's nothing but the vertical line, the longest, we have to identify a longest vertical line which doesn't cut by a horizontal line. As you can see, all these vertical lines, this horizontal line crosses through a vertical line. So here the ideal number of clusters is either 4 or 5 in my opinion. And this can be actually seen by another example which is much more clearer than this. So imagine we have a data set distributed like this, and we um, try to do a hierarchical clustering on this. And when we represented our linkages or the cluster merges in a dendrogram, as you can see, we have a vertical line which doesn't get crossed by a horizontal line. So in this case, ideal number of clusters are 2. That's how it is represented as. So we have seen these three topics. Next comes the linkages. Before going to the linkages, let me explain how agglomerative clustering works. As we know, it merges the uh, points which are close to each other and eventually the clusters. But how is the proximity matrix calculated? Initially, as we know, each of the points is its individual cluster. So how the proximity matrix is calculated is it finds the distance between the data points. So if there are say 2, 5, 7, 9. So there are 12 data points initially. So we'll have a proximity matrix calculated for all the 12 data points. So this so on till P12 and this so on till P12. Okay. So initially this value will be 0 because the distance between point 1 to the point 1 is 0, and say some distance for P1 to P2 and so on. So after the proximity matrix is calculated, uh, it forms, as you know, of the first iteration, it merges the data points into a cluster. So, sorry. So imagine these are the clusters formed after the second iteration. So C1, C2, C3, probably let's say 5 clusters are formed. So at the second iteration, we again recalculate the proximity matrix, that is between for the 5 clusters. This in basically we'll be calculating the intra-cluster distance between these 5 clusters, and we'll identify the clusters which are close to each other. Let's say the cluster C2 is close to C5. Then we will merge these two clusters here as shown, and we will recalculate our proximity matrix. As you know, we had merged C2 and C5. Here we have to recalculate the proximity matrix, and these values remain as is. The distance from cluster C1 to C3, C1 to C4, all these remain as is. Only thing that gets that has to be recalculated is this row and this column as we merge C2 and C5. And eventually, when the proximity matrix, like we cannot further merge, we calculate the proximity matrix so on. So this is how agglomerative clustering works. Next, here we calculated the distances between the clusters, right? There are different ways to do that. So, and let me open this PDF which has a good explanation. The ways to calculate the intercluster distances: a min approach, max approach, group average, and a ward method. So what min approach states is, this is also called as a single linkage. So what it states is, so after the first iteration, when the clusters are identified in the first iteration, in the second iteration, the data point, basically it finds the minimum distance between the clusters. So here cluster 2 and cluster 1, it finds the minimum distance between these two clusters, and same it finds the minimum distance between cluster 1 and cluster 4, basically the point 4. So eventually what happens is it identifies 2 and 3 are close to each other, hence it merges these two clusters into forming a cluster 3, and this process repeats so on. We form a single big cluster. This is a minimum linkage method. Next, uh, what is a max linkage? Max linkage is also called as a complete linkage. What it states is, once the individual clusters are from the individual clusters, when a group of clusters are identified. For the second iteration, it tries to find the maximum distance from a cluster to another cluster. So in this case, 5 and 6 data points which are present in cluster 1 and cluster 2 are very far from each other. Now, this data point 4, how far, like, basically we calculate the distance, maximum distance from 4 till cluster 2 and cluster 1. And then where the distance is minimum, it merges it. So in our sorry, in our minimum linkage method, we saw this cluster 1 and cluster 2 got merged to form cluster 3, whereas in maximum linkage method, it merges, cluster 1 gets merged with data point 4 rather than cluster 2. So this is one key difference between a single linkage and complete linkage. And advantages of minimum linkages, say if the data is distributed like this, when there is no noise between these groups, then minimum linkage works really well. It identifies individual clusters. But whenever there is a noise, like some sparse data between two groups, it doesn't work well, minimum linkage. And maximum linkage, when there is noise between the groups that we identified, maximum linkage works well over there. However, when say one of the clusters is very dense, then there is a chance that maximum linkage might fail, because as you can see, initially there are two big groups or clusters. When we apply maximum linkage method to this, what happens is, if a data point initially in the original group, this data point belongs to say cluster 2, but because of maximum linkage, this point might be closer to this cluster, hence it there is a chance this groups to the cluster 1, and it breaks the original structure of the cluster. So here the maximum linkage fails. Let's look at the one of the examples of hierarchical clustering. So I have taken a data set, and it has a distribution between age and income. And initially, when I apply hierarchical clustering using a word or min or max approach, this how it is represented as. My hierarchical clustering is present in scipy.cluster package, and if I want to see the dendrogram, it's present in dendrogram is present in hierarchy class, and this how it is represented as. And if I want to do agglomerative clustering on that data set, so and which distance method I want to use, so I'd be using equilibrium distance, and the groups of the data is grouped into its clusters.